Ligentec are makers of photo-integrated circuits, and they make them for clients all over the ground and space sectors. I'm really pleased to say I've been joined by their CEO, Thomas Hessler. Thomas, thanks for joining us. I want to talk a little bit about some of the use cases and applications that you're working on, and we'll get to that in a moment, but really keen to explore a little bit on, you describe silicon nitride as king. Why is that, and why do you feel so strongly about it?
Well, that's a marketing slogan. The technology itself is rather young and novel, and we have to wake up the community a little bit. And there's always more than one king, so it's not that silicon nitride will solve every problem. But there are, and maybe if you come to the applications later, there are specific problems where silicon nitride offers a lot of benefits. Just to name a few, the silicon nitride is transparent from the blue all the way to the mid-infrared compared to other technologies which cut below 1 micron. And it can handle a lot of power. So, for example, we had waveguides which are about less than a micron by a micron, and they could carry up to 10 watts. So that's, I think, 10 to the whatever 9th watt per square meter, or 18th. It's a huge number of power density you can carry in silicon nitride, which is quite relevant for applications like, for example, long-range lidar. So there are some specific benefits which we feel in these market application areas it is king, yes indeed.
Okay, well let's talk a little bit about some of those applications. You mentioned LiDAR there, but also important for things like quantum computing too. So maybe there's a couple of things you can give us a bit more detail on.
Yeah, I mean, first of all, if you talk about PICs, you think about communications data centers and also long-haul communication, coherent transceivers. And that's where silicon photonics, SOI photonics, is traditionally strong. And so for that reason, and because we offer benefits in the other markets, we are focusing more on the new applications like quantum computing. And in quantum computing, the losses of the waveguide losses are key. I mean, if you have an entangled photon pair, you don't want to lose it. You want to carry it as long as possible. And the more loss you have, the more error correction you have to do. And there's a limit where you can't do any quantum computing anymore. That's why the people say every photon counts, and so the really low losses of silicon nitride is really king in that application space. And that's why we get a lot of traction from that market at the moment.
Okay, brilliant. Well, it's a massive growing market, so it'll be interesting to see how that develops. One thing I wanted to ask you about, it's been a year now, you've had 1 year in partnership with X-Fab. How is that partnership going, and what's that delivering for you?
I mean, it's the beginning of a great journey, and we've been together more than a year, but we announced it a year ago. And I feel we are just at the early stage beginning. We have now all our process installed in the foundry ecosystem. We are now able to deliver 200 millimeter wafers in volume out of that. And now we are moving kind of to prepare for the next steps, and that goes into heterogeneous integration. So put actives on the nitride, lasers, modulators, and detectors. So there is much more to come in the future.
Fantastic. Well, we look forward to hearing more from you maybe in future exhibitions here. But for now, Thomas, thank you very much for coming over and talking to us.
Thank you.